11.2 is on central angles and arc measures. So for today, we are going to be able to explain and use the formula for arc length. So our warm-up example, we would need to find the value of each variable. Remember, when we have angles that form a straight line angle, they have to add up to 180 degrees. And knowing that, and we know that x and y are marked congruent, so x is equal to y, we can write an equation where we add all of the angles together and put it equal to 180. And because we know x and y are the same thing, we can replace the y with an x. So we would have 70 plus 40 plus x plus x, and that is equal to 180. So we can combine these, and we would get 110 plus 2x, and that's equal to 180. Then to solve for x, we would subtract the 110 on both sides, and we would get 2x is equal to 70, and lastly we need to divide by 2. When we're done with that, we get x equal to 35. And if x equals 35, we also know that y has to equal 35 as well. So that would be our final answer. To complete today's homework, we are going to need to know a little bit of vocabulary. So our first vocabulary, again, we are working with a circle. So to start off with, we're just going to draw a circle in the space provided here. There we go. And then we are going to start filling in the vocabulary. So a central angle is an angle in the circle, and the vertex of the angle is going to be at the center. Vertex on the center. So if we draw the center of our circle in the middle, a central angle is just going to be this angle here. All right, next we have a minor arc. So first, in order to do that, we need to know what an arc is. And an arc is just a curved portion of the circle. So a minor arc is going to be a curved portion of the circle that is less than 180 degrees. So basically, it just has to be smaller than half of the circle. So for example, if we labeled these 2 points A and C here, this would be an example of a minor arc going in between AC. And the way that we would label this is arc AC. So a minor arc is always labeled with 2 points with a little curve above it. Then our next vocabulary word is a major arc, and this is going to be an arc that is more than 180 degrees. So this one, when we label it though, we do need 3 points. So an example of a major arc would be going this direction. And we would label it with 3 points so we know which way we're going. So this one would be labeled with arc A, B, C. And then lastly, we have a semicircle. Oh, it's already written, sorry. And a semicircle is an arc that is equal to 180 degrees. So basically it's equal to an arc that's half of the circle. So if we were to draw a diameter here, so if I just continue this line, so this is our diameter, and we could label this point D. So a semicircle would be going from A, C, D. And this one is also labeled with 3 letters. So this one would be arc A, C, D. And this would be all of the vocabulary that we need for today. Alright, so next we're going to be talking about the measures of the arcs. So the measures of the arcs are equal to the measure of the central angle. And it's going to be the central angle that forms the arc. And knowing that, we are going to be able to complete example 1. In example 1, they want us to classify each of the arcs and find the measure in circle P. And they told us that RT is the diameter. So if we start with arc RS, we have that arc, and it is cut off by the central angle of 110 degrees. So that means our arc is also going to be equal to 110 degrees. And because that is less than 180 degrees, this is going to be a minor arc. Next, we're looking at RTS. And when you follow the letters, you want to make sure you're going in order. So we're going from R to T and then T to S. So if we look at this one, we know from this point, from R to T, that is 180 degrees. And same thing on the other side, it's also 180 degrees. So to find the missing portion, we're just going to take 180 minus 110 to get 70 degrees. Now we can figure out what arc RTS is equal to. And there's 2 different ways. So we could either do the 180 plus 70, and that will get us 250. The other way would be taking 360 minus 110. And the reason we can do that is because arc RTS takes up the entire circle except for the portion that's covered by RS. And you'll notice we end up with the same answer. So it's going to be 250 degrees. And this one is a major arc because it is more than 180. And next we're looking for RST. And that one covers half of the circle. So that means it is going to be exactly 180 degrees, which makes it a semicircle. All right, so that lets us move on to our next example. So example 2, a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or some other person. The results are shown in the graph circle, and they want us to find the indicated arc measures. So the first one is AC. So in order to find these arc measures, we are just going to add the values that we cross on the way of the arc. So for this one, we're going to take 29 plus 108. And for that, we would end up with 137 degrees. And these are degree measurements, so don't forget to put the degree symbol on your final answer. Okay, next we're looking at ACD. So this one's going to be a little bit bigger. So we can use that 137 that we already found, and then we're going to add the 83 because we're going that much further. And for this one, we're going to end up with 220 degrees. And next we're looking at ADC. So this time we're going the opposite direction. And there's a few different ways you can do this. If we continue with what we've previously done, we're just going to add up all of the arcs that we have already got. Okay. So let me, 80, let's see. So 79 plus 61 plus 83, be 13, 7, 8, 16, 22. So we would get 223 degrees for our third answer. And lastly, arc EBD, from E to B and then B to D. This one, we are using the entire circle except for the other part. So to do that, we could add 79 plus 29 plus 108 plus 83, or knowing that the entire circle is 360 degrees, we can just subtract the one portion that we're not using. So we would end up with 299 degrees for our final answer. All right, looking at our next example, if you feel like you have, you understand this pretty well, you can skip this part of the video and continue on to the next part. If you would like to fill in this example, you can do that as well. So starting off with arc TQ, that one is going to be equal to the central angle of 120 degrees. Next, we have QRT. So this goes around the whole circle except for the 120. So we can take 360 minus 120 to get our answer, and that will leave us with 240. Next, we have TQR, which goes this way. So to get that answer, we would take 120 plus 60. And that would give us 180 degrees. Then we have arc QS. So this one, we do need that missing portion of our circle, which we haven't found yet. So we know that 120 and 60, those added up to 180. So that means this other side of the circle has to be 180 as well. So if we take 180 minus 80, we know that this is 100 degrees here. So to find QS, we would take 100 plus 60 to get our answer of 160 degrees. And then next we have TS, which just goes this way. So that's going to be 80 degrees. And anytime you only have two letters naming an arc, you are going to take the shortest distance between those two. So anytime it's just those two letters, you do the shortest distance. And lastly, we're going from RST, which would be 100 plus 80, and hopefully we already know that that is 180 degrees. So our last step would be just labeling these if they're major, minor, or semicircles. So anything greater than 180 is going to be a major arc. So for this one, we just have the 1. Anything less than 180 is going to be a minor arc. And remember, it's less than 180, not equal to. If it is equal to 180, then it is going to be a semicircle. And then we are now done with the problem. Lastly, we are going to be talking about congruence. And two circles are congruent if and only if they have the same radius measure. Which makes sense. If they have the same radius, that means the circles are going to be the same size. Then two arcs are congruent only if they have the same measure and they are part of the same circle or part of congruent circles. So we're going to go through 3 examples telling whether or not the circle arcs are congruent or not. So if they're congruent, they have to first be part of the same measurement. So 1, same measure. And for this one, they are both 80 degrees. So this one, yes, they have the same measure. Then for part 2, they need to be in the same circle or congruent circles. And if we look at this one, they're both in the same circle, so yes, they are. If both of these are yes, then we can say arc CD is congruent to arc EF. If one of them is no, then they are not congruent. Okay, so if we look at example 2, do these two have the same measurement? And they are both 90 degrees because they're central angles. So this one, yes, they do. Are they part of the same circle? No, because one's on the inside and one's on the outside. Or are they a part of a congruent circle? And again, no, because one circle is bigger than the other. So for this one, arc RS is not congruent to arc TU. And finally, our last example. Do they have the same measurement? And that one's going to be yes, because they are both 95 degrees. And are they part of the same circle? No, but they are part of congruent circles because the radiuses are the same. So this one is still going to be a yes. So we know VX is going to be congruent to arc YZ. And that is our final answer. If you have any questions, just let me know. And then you should be able to complete the homework. And don't forget to check your answers with the key on school.